Welcome back to our channel Machinery and Technology. Today we have a truly electrifying topic, giant gearbox manufacturing process. For the gearbox manufacturing process, the most important thing is the material. However, the surface finish of the gear well, process cost, gear type, quantity and quality is very important. So if you're ready to spark your curiosity, let's dive in. Manufacturing a giant gearbox involves several intricate steps, and the specific process may vary depending on the size, type, and applications of the gearbox. These gearboxes are commonly used in heavy industries like mining, wind energy, and heavy machinery. Here is a general overview of the manufacturing process. Design and engineering. The process begins with the detailed design and engineering. Engineers consider factors such as the torque requirements, speed, load capacity, and environmental condition to design the gearbox. Material selection. High-quality materials, often alloy steels, are selected based on the gearbox specification. The materials are chosen for their strength, durability, and resistance to wear and corrosion. Machining. Giant gearboxes typically consist of the large gears and housing components. The manufacturing process involves extensive machining to create these parts. Machines are commonly used to precision cut gears and other components. Heat treatment. After machining, the components undergo heat treatment process like quenching and tempering to improve their strength and durability. Assembly. Gear components, shaft, bearings, and other necessary parts are assembled in a clean and controlled environment. Precision is critical to ensure proper alignment and functionality. Lubrication. Gearboxes require proper lubrication to reduce friction and wear. Lubrication systems are integrated into the gearbox design, and the gearbox is filled with appropriate lubricant during assembly. Quality control and testing. Comprehensive testing is conducted to ensure the gearbox function is attended. This may involve load testing, vibration analysis, noise measurement, and thermal testing. Any issues found are addressed before the gearbox is shipped. Painting and coating. For protection against corrosion and environmental elements, the gearbox may be painted or coated with a suitable finish. Packaging and shipping. Once the gearbox passes all quality controls tests, it is carefully packaged for transportation to the customer's location. Given the size and weight of giant gearboxes, special shipping arrangements may be necessary. Installation and maintenance. Upon arrival at the installation site, the gearbox is installed integrated into the relevant machinery. Regular maintenance is essential to ensure the gearbox's long-term performance and reliability. The manufacturing process for giant gearbox involves specialized equipment, skilled labor, and strict quality control to ensure that these critical components meet industry standards and perform reliability in demanding applications. Additionally, manufacturers often provide support and maintenance services to the customers to maximize the lifespan and efficiency of their gearboxes. Challenging in machining gears for wind turbines. Gears designed for the wind turbine application present unique challenges due to their large diameter and wide face widths. Precise material composition and heat treatment processing are crucial to optimize gear performance, ensuring low rolling resistance and extended lifespan. Maintenance costs, downtime, and repair expenses for gearbox assemblies post-commissioning emphasize the need for the meticulous manufacturing process. Carburized steel is commonly used for these gears, require exacting heat treatments and stress relief operation to minimize part distortion and achieve the required metallurgical properties. Preheat treatments may be necessary for large gears to minimize distortion. Employing the vertical insertion technique during the heading phase reduces distortion risk. Heat treatment can lead to cracks, necessitating carefully processing with a penetrating stock allowance for grinding and achieving the final case depth. Inspection methods like magnetic particle inspection and initial etching are essential for detecting cracks and grinding burns. Modification to tooling and machine tools. For coarse speed gears, rigid heavy-duty hobbing machines using roughly hubs or gear milling, cutters are necessary. Coarse pitch diamond dressing rolls, a special grinding well observes, are indispensable for large high-accuracy gear grinders to prevent grinding burrs and cracks and achieve efficient, accurate results. Cutting fluids used should have the proper viscosity and their right amount of extreme pressure additives, precisely directed to the workpiece, and a cutting tool furthers the optimal outcomes. Routine sampling and adjustments are vital to maintain fluid effectiveness. special consideration in gearbox building. Establishing correct bearing clearance preloads are crucial for gearbox longevity and proper operating temperature. Advanced measuring techniques with a bearing inspection ensure accurate results. The type and method of lubrication and proper sealing significantly impact gearbox performance. Computerized analysis and testing verify gearbox performance, warranting extended life. Ancillary requirements in a gear preparation to wind turbines application. Special work holding and fixturing are crucial to support the weight and reduce vibration and movement of the gear blank during hobbing and roughing. Uniform torquing of clamping fasteners prevents workpiece movement and a gear blank distortion during roughing operations. Accurate mounting and indicating surface of the gear blank are necessary to control pitch line runout to critical features and minimize lead error. Properly designed and manufactured gears, along with compatible mechanical components, ensure optimal system performance without shortcomings that could affect unit life. Precision and care during sub-assembly or assembly lead to favorable outcomes.